At this time, I'm going to go through the steps we need for the homework, which was solving some problems using completing the square. And these problems will be very similar to what we're going to see in the quiz tomorrow. So I'll start with this problem right here, x squared minus 6x plus 1 equals 0. You can try to factor that. There's no way I'm going to get numbers that multiply to 1 and add to 6. Doesn't work. So we have to go to completing the square. So the first thing we want to do is get rid of this 1 because that's not the number needed to complete the square. So I would write x squared minus 6x, and I'm going to leave a space, equals negative 1. Now, there's going to be a space here as well, but whatever I put here on the left side, I have to add to the right side as well. So the number that goes here is half of negative 6, which is negative 3 squared. So negative 3 times negative 3 is positive 9. So since I added 9 to the left side, I have to also add 9 to the right side. Now this problem, to factor this, it's just going to be x minus 3 squared equals 8. Basically, half of this number will go here within the square. And now I can go through the steps to, I can say x minus 3 squared equals 8. I can take the square root of both sides. Now when I take the square root, I need plus or minus. So this is going to be x minus 3 equals plus or minus the square root of 8. So now I add 3 to both sides, and I get x equals positive 3. 3 plus or minus the square root of 8. Now we typically would not leave the square root of 8 because that can be simplified. So I would say that's going to be 3 plus or minus 2 square root of 2. Because remember, square root of 8 is square root of 2 times 2 times 2. Under the square root, we recall that two of the same things will come out. One comes out and the other one goes out front, crosses off. So I have 2 root 2. So this would be what our final answer would look like for this problem up here. Number 2 is going to be a little bit trickier because I have a 7 and I have a 1. I first want to get rid of that 7, subtract 7 from both sides. These are going to cancel. And I have x squared plus 10x, remember I'm going to leave a space, equals negative 6. At this point, I want to figure out what number should I add to both sides. Half of 10 is 5. 5 squared is 25. So that's going to be plus 25. And we're choosing that number for a very specific reason. The reason we decided to add 25 to both sides of the equation is because the left side now will become a perfect square, which is going to be x plus 5. If we wanted to go through the factoring method, we could say numbers that multiply to 25 and add to 10, that's 5 and 5. So x plus 5 times x plus 5 becomes x plus 5 squared. But the quick way to do it, as long as this coefficient is 1, it's just going to be half of that number. In the right side now I have 19. So now I'm going to take the square root of both sides. So the square root of the left side and the square root of the right side plus or minus. Now on the left side, the square root and the square cancel, and I got x plus 5. On the right side, I have plus or minus the square root of 19. And now it's one last step. I'm just going to subtract 5 from both sides. X would be equal to negative 5 plus or minus the square root of 19. Okay, this problem is similar. I have to get rid of this 20 somehow. Not the 20, excuse me. It's already set up to do this. I can write x squared minus 20x, leave a space, equals negative 19. At this point, what I'm going to do is add a constant to both sides. Half of negative 20 is negative 10. Negative 10 squared is negative 10 times negative 10, which is plus 100. And this side is plus 100. And now this is going to factor to be x minus 10 equals 81. X minus 10 squared, sorry. Now when I take the square root of both sides, I have x minus 10 equals 9. What did I write 2? X minus 10 equals 9. Now there's no square root left because this is a perfect square. And this plus or minus 9, which means I could say x minus 10 equals 9. X minus 10 equals negative 9. And that becomes add 10 to both sides. X equals 19. Add 10 to both sides. X equals 1. So those would be my two solutions. There's other ways. When I get rational numbers here, no square roots, I could have done this by factoring. If I decided to, if I had this, let's say I did it by factoring, I'd say x squared minus 20x minus 19, equals 19, equals negative 19. I could add 19 to both sides, and I'd have x squared minus 20x plus 19 equals 0. I would factor that. I'd say x minus 19 and x minus 1 equals 0. X minus 19 equals 0, x equals 19. X minus 1 equals 0, x equals 1. And I get the same answer as I did over here on the left. This method of factoring is much easier. The only problem is it doesn't always work. It does work in this case, and in that sense, if I just told you to solve, this is probably a better way to do it over here. All right, let's move forward. This one, I have to get rid of this 3 to start with, so I'm going to subtract 3 from both sides. And that gives me x squared plus 2x equals negative 3. At this point, I want to take half of 2, which is 1, and 1 squared is 1, so I put plus 1, and here plus 1 as well. So that gives me x squared, no, back up. I can factor the left side, and remember, I picked this number here so that it would factor very quickly. X plus 1 squared equals negative 2. So now when I take the square root of both sides, I get this side over here, and I get plus or minus that. Now this becomes x plus 1, but the right side becomes plus or minus I times the square root of 2. Because the negative under a square root becomes out of the square root as an I, and I'm left with the square root of 2. So now I'm going to subtract 1 from both sides, so x equals negative 1 plus or minus I times the square root of 2, and that's fine. If you wrote it negative 1 plus or minus the square root of 2 times I, that would be acceptable as well, actually probably better, but most books and tests and quizzes will write it like this, standardized ones at least. Now number 5, I've got to first get rid of this 2, so I'm going to add 2 to both sides. X squared plus 7x equals 2, and I left me a space. Nice English. I left a space for myself. So now I've got to take, half of 7. That's going to be a mess because I have fractions. So I can either put 3.5 squared or plus 7 over 2 squared plus 7 over 2 squared, because 7 over 2 is half of 7. So that becomes, I'll just write it out, x squared plus 7x plus 49 over 4 equals 2 plus 49 over 4. And now this left side becomes x plus 7 over 2 squared, just like that. Half of 7 goes here. And now this, to add that fraction, that's going to be, I'll do it over here in a different color. 2 can be written as 8 over 4. This is just 2, which is the 2 from here, plus 49 over 4. And the reason I chose that, of course, is so that I have common denominators. And 8 plus 49 is 57. So this is going to be 57 over 4. And now I'm going to go through my next step to get rid of this. I take care of square root of both sides. and that becomes x plus 7 over 2 equals, now I'm going to change this around to say that's going to be plus or minus the square root of 57 divided by the square root of 4, which is the square root of 57 over 2, plus or minus, because the square root of 4 is 2. And it looks similar, but here the square root includes the denominator, and this last one it does not. So I'm going to write it like the last one is, and say plus or minus the square root of 57 over 2. And now what I have to do is get rid of that 7 over 2. So I'll go through my algebra skills and just say minus 7 over 2. Minus 7 over 2. These are going to cancel. And I have x equals negative 7 over 2 plus or minus the square root of 57 over 2. And we just leave our answer just like that. Although sometimes you might see this, negative 7 plus or minus the square root of 57 all over 2. I'll take either one of these methods. All right, number 6. Let's go through the steps for this one. We're going to add 5 to both sides. Left side's going to cancel. I'm going to have x squared plus 3x, leave a space, equals 6. I take half of 3. Half of 3 is 3 over 2, and 3 over 2 squared. So I'm just going to write this. 3 over 2 squared is 9 over 4. So that's going to be plus 9 over 4 here, and plus 9 over 4 here. That becomes x plus 3 over 2 squared equals, now 6 is 24 over 4 plus 9 over 4. 6 is the same as 24 over 4. So that's going to be 33 over 4. So I'm going to write 33 over 4. And similar to the last problem, when I take the square root of both sides, I take the square root of this side and the square root of this side plus or minus. And of course, that's going to be equal to the square root of, let me erase this over here. That's going to be the square root of 33 over the square root of 4, which is the square root of 33 over 2, and plus or minus. So then I have x plus 3 over 2 equals plus or minus the square root of 33 over 2. And now I need to get rid of that 3 over 2, so I'm going to subtract 3 over 2 minus 3 over 2, and these will cancel, and I have x equals negative 3 over 2 plus or minus the square root of 33 over 2. This would be acceptable. A lot of times we'll see it like this. All over 2. That sometimes is taken. I'll take either one of these. That's the solution. Now, what if we wanted, could we done this with, I wonder if we can do this with decimals. Would that really work? And sure, what would happen is this would be 1.5. So I'd have 1.5 squared, which is 2.25. So the problem would look like I'd have, let me just do it in blue. I would have x squared plus 3x plus 2.25 equals 6 plus 2.25. It just comes a little bit crazy with this. That becomes x plus 1.5 squared equals 6 is 8.25. It just becomes, I wouldn't really use this method unless I have decimal approximations to deal with, because now I've got to take the square root of 8.25, which is kind of a weird way to do it. I would suggest doing it with fractions all the time. All right, the next couple of problems are going to be a little issue for us because we have a 2 in front of this. So for these problems, actually the first thing we can do for all of these, I want the first leading coefficient, the one of the x squared, has to be 1. So what I'm going to do is I'm going to divide by 2. And I can't just divide this by 2 unless I divide everything by 2. And these cancel. This cancels to be a 4, and then this just looks like this. So I have x squared plus 4x plus 1/2 equals 0. So what I'm going to do is x squared plus 4x equals negative 1/2. I subtracted 1/2 from both sides. And then I have, I got to figure out what number should I put right here to make it a perfect square. 1/2 of 4 is 2. 2 squared is 4. So plus 4 plus 4. So I have parentheses x plus 2 squared. Remember, this number here is half of this coefficient here. So that equals, now negative 1/2 plus 4 is negative 1/2 plus 8 over 2, using a common denominator of 2, which is 7 over 2. So this would be 7 over 2. And now when I take the square root of both sides, plus or minus, so I have x plus 2 equals plus or minus the square root of 7 over 2, which equals plus or minus the square root of 7 over the square root of 2. And we know we can't have squares in the bottom. We go back to our file cabinet of our brain and figure out, wait a minute, there was a method of getting rid of that. That was to say square root of 2 over square root of 2. So that's going to be plus or minus the square root of 14 over 2. So this becomes now x plus 2 equals plus or minus the square root of 14 over 2. And now I'm going to subtract 2 from both sides. Minus 2, and I got x equals negative 2 plus or minus the square root of 14 over 2, like that. And that's really how we would write it. If you saw it like on a multiple choice test, it might be written like this. Negative 4 plus or minus the square root of 14 over 2. The reason for that is I can write this negative 2 as negative 4 over 2 and then combine terms. But this method would be the accepted method for me. Okay, and the last problem is similar. We got messed with this 4, so I need to get the leading coefficient, that's the x, 1 in front of x squared, to be 1. So I'm going to divide by 4. I'm going to divide by 4, and I'm going to divide by 4. And I'm dealing with fractions, but so what? We just have to learn to deal with them. So x squared plus 5x plus 3/4, or not plus, equals 3/4. And remember, we're going to leave a space, equals 3/4. And there's a space over there. So now half of 5 is 5 over 2, and 5 over 2 squared is 5 squared is 25, and 2 squared is 4. So plus 25 over 4. That looks like it's not going to be too bad, because I look over here, when I add 25 over 4, here I have common denominators already. So this is going to be x plus 5 over 2 squared equals 28 over 4. 3 plus 25 is 28, which equals 14 over 2. Remember, plus or minus. Oh, I'm sorry, not yet. I'm going to do this right now. I'm going to leave it like this because when I take the square root, I'd like that to be 2 on the bottom. I'm going to go through the steps now to finish up. I'm going to say square root of this and square root of that. Oh, you know what? The plus or minus wasn't there yet. Sorry. Well, it is there now. Whatever. Yeah, that was, when I take the square root, it's plus or minus. That should be in blue. So x plus 5 over 2 is equal to plus or minus the square root of 28 over the square root of 4, which is plus or minus the square root of 28 over 2. So let's finish this problem a little bit. We're going to subtract 5 over 2. from both sides. So the left side is going to be x, and it's going to be negative 5 over 2 plus or minus the square root of 28 over 2, which would be equal to negative 5. We usually will write it like this, plus or minus the square root of 28 all over 2. But the square root of 28, remember 28 is 2 times 2 times 7. So to finish that problem off, these guys combine together to be the same thing. One of them crosses out and the other one goes in front. So it's negative 5 plus or minus 2 square root of 7 over 2. And believe it or not, you are expected to be able to put the answer in that form on the Regents exam. All right, that's a little long of a video. I apologize for that, but hopefully it helps a little bit. That's it.